All right, so let's start. Anybody have any idea what is an absolute value? I know it's a mathematical operation, but what is it really asking me to do in terms of actually performing that operation?
Using the positive version?
Yeah, you are taking a positive version. If you take the absolute value of 5, it is 5. But what does an absolute value in its basis, what is it telling you to do? And what I'm asking you really to do is to have a very specific definition for absolute values. And an absolute value is something very, very simple. And let me write it down so that way you guys know the definition. So in the most simplest of words for a definition of absolute value, an absolute value of a number is literally just its distance away from 0. Now, of course, there's a way to find the absolute value, but for the most part, that is literally the very basics of what an absolute value is really just telling you to do. So let's say I have this number line here and I want to find the absolute value of 4. Well, what is the absolute value of 4? When I ask you for that, you guys need to be thinking, okay, this guy's asking me for the absolute value of 4. All he's really asking me is what is the distance away from 4 to 0? And we can see here that the distance would be 4. Pretty kind of straightforward. Again, just like you said, an absolute value of a number is just really the number. Now, keep in mind that things could change a little bit, especially if you're dealing with negatives, but not really. And let me show you what I mean. Let's say I'm trying to find the absolute value of 5. Well, think in your head, how far is negative 5, to be more specific? How far is 5 away from 0? And what would you guys say? How far is negative 5 from 0?
5.
5.
Five.
Exactly right. So you'll notice here that the absolute value of a negative 5 is just 5 because its distance away from 0 is 5. The absolute value of 4 is 4 because the distance away from 0 is 4. Now again, I'm not going to ask you for absolute value, especially when writing it down. You need a way to mathematically show it. And that is what we are going to do down here. Let's say I give you a value for a, and that a could be any number, but it has to be greater than or equal to 0, aka positive. Well, then if I'm trying to find its distance away from 0, I'm going to mathematically show it by drawing 2 vertical lines on either side of what I'm trying to find the distance of. Now you'll notice that if I'm trying to find the absolute value of a positive number, it literally just equals that number. More specifically, let's use a specific example. Let's say for some reason I want to know the distance away from 0 of 12. Well, how far is 12? What's the absolute value of 12? It's just a positive 12. Keep in mind that when you actually find the distance, the absolute values do have to disappear a little bit. So again, what I'm trying to get here in this lesson is not just to do things mechanically. Think in the back of your guys' heads and have those thoughts that like, okay, this guy's not just telling me to rewrite it without bars. He's asking me to find a distance away from something. So when we build on it, it isn't as, how would I say, just mechanical. It's more conceptual. Now, let's go ahead. Keep in mind that if a is greater than or equal to 0, that means it's positive. Let's say I give you a value for a that is less than 0. And I want to find its distance away from 0. Well, then that means it's just going to be an opposite of whatever that negative number is. Now, this is super mathematically talk. Let me show you what that looks like with a specific negative number, because if a is less than 0, it's always going to be negative. I don't know. Let's just do a negative 10. Let's say I want to know the distance away from 0 that negative 10 is. Well, I'm going to then find the absolute value because that's the operation that's going to allow me to do that. Now, notice I'm taking the absolute value of negative 10. Again, if you're taking the absolute value of a negative, you just take the opposite. So a negative 10, the opposite of a negative 10 is just a positive 10. Now, I know what you guys are thinking. You're like, man, this is kind of very complicated way of explaining just if it's negative, make it positive. If it's positive, leave it positive. But you guys are starting to get to the level where you guys are gonna have to get used to this math talk. And I think you guys know by now in your math class that sometimes simple things in math are a little more complicated. But when you go and you build on it, you'll notice that these things are super, super important. So that's the basics. What do you guys think? Are you guys okay with this? Do you guys know what an absolute value is in its basics before we start moving on to problems?
Yeah.
Yeah, brain's okay. I need everyone to let me know. Everyone ready?
Yep.
All right.
Yeah.
Yep.
Yeah, everyone sounds so excited. I'm excited too.
Yeah.
There we go. There you go. Extra credit for you.
I appreciate that.
No problem. So now everyone's gonna be really excited. So let's start with evaluating expressions first. And then we'll start moving on to equations, and there's little tricky things that I want you to watch out for. So keep in mind here that we are evaluating expressions, and we learned about expressions are just numbers that express a value. So if you look at number 1, this is -3 times the absolute value of 3 squared minus 2 squared. You need to figure out what all this equals. What is all those string of numbers and operations expressing? Now, we did some problems at the beginning where we practice, when we have a string of things like this, that we practice PEMDAS, the order of operations. Now, remember that P is parentheses, X, E is exponents, M and D are multiplication, division, and then addition and subtraction. Where does absolute values fall in the priority list? And the answer is very, very straightforward. It is on the same level as parentheses. Treat parentheses or absolute values as parentheses. So if I give you this string of numbers and I want you to find out what those equal, refer to your rules or your order of operations, your PEMDAS, but also keep in the back of your mind that absolute values are pretty much parentheses. You want to treat them as. So as I read this, this is -3 times the absolute value of something. You need to figure out what the something is and take the absolute value of it. So I'm going to concentrate on everything inside of this absolute value. I'm going to simplify it, and then I'm going to take the absolute value and deal with the aftermath. So looking at everything inside there, what I've underlined that's inside the absolute values, are there any parentheses? And the answer would be no. Are there any exponents? Yes, there are 2 of them. Let's go ahead and simplify those. 3 squared is 9 minus 2 squared, and then again 2 squared is just a +4. Don't forget that we're taking the absolute value of these. Now, looking at everything inside those absolute values, I can see that there's only one operation, 9 minus 4, which is a +5. And then finally, I can take the absolute value of it, which is a +5. Now, keep in mind that I need all the help I can get in my life. I am not a good multitasker. I have to worry about one thing at a time. And that is why I underlined everything underneath the absolute value. I simplified it, and now I'm going to deal with everything else. Notice I completely forgot about the -3, or kind of really just left it off to the side. I'm going to go ahead and fill it out for the rest of my math. Now, notice that this -3 was multiplying whatever the absolute value was. Now I figured out what the absolute value was. It's +5, so -3 times 5 is just a -15. So this whole string of operations and numbers expresses a -15. All right, so any questions on that one before I ask you to do number 2 and 3? If you're feeling confident, go ahead and do number 1 at the bottom with variables. Yeah, is there anything I can answer for number 1 or clarify? All right, so finishing up this problem right over here, notice that it is my job to figure out what all that junk equals. Now, there are a bunch of operations, but knowing my order of operations is going to help me figure out which one to do first. So I have 2 times the absolute value of something plus the absolute value of something. I know that I have to do parentheses first. So luckily for me, there are no parentheses. But now I need to do all the work within them, within those absolute values. So I can see here that I have -3 minus 2. -3 minus 2 is just a -5. Now remember, you're taking the absolute value of it. Now looking at these absolute values, I have 3 plus 2, which is a +5. I still need to take the absolute value of it. Now, before I go any further, I'm going to go ahead and write everything else around it to make sure I don't forget it. Now let me go ahead and actually take the absolute value of -5, which is a +5. Now, again, don't forget that this 2 is multiplying, so I'm going to show multiplication with parentheses just because, I don't know, I like to show multiplication with parentheses. Now, the absolute value of 5 is a +5. So now I notice that I've solved everything within the absolute values. I took the absolute value of pretty much my final result. And now I'm ready to deal with the aftermath, which is 2 times -5 plus 5. Don't forget your order of operations. I can see here that the first thing that shows up is multiplication. 2 times 5 is a -10. Oh, forgot something there. What did I forget?
Absolute value.
The absolute value, exactly right. So the absolute value of -5 is a +5. So don't make those simple mistakes like I just did. Now let's go ahead. I think I've done everything correctly after that. So 2 times a +5 is a +10. Don't forget to add 5. Then 10 plus 5 is also, or is a +15. All right, everybody agree with me?
Yep.
Yes.
Mm-hmm.
Thank you, thank you. So looking at number 3 here, notice that I have the absolute value of something divided by 5. So let's figure out what all this junk in the middle equals. Now looking at that, I can see the first thing that shows up are exponents. So 2 to the 3rd power is 2 times 2 times 2, which is a +8. Don't forget to minus the 4. 8 minus 4 is a +4. Absolute value of a +4 is just 4. Notice that I drag that 5 over. I can't reduce 4 over 5 any way, shape, or form. So that means I am done with that problem there. I've simplified it as much as I can, ready to move on. So you'll notice here that the way I set up these problems, I wanted to ensure that you guys felt comfortable solving or really simplifying expressions with absolute values. Now I'm asking you to substitute, which is pretty much the same thing, just a little bit of a pre-step. I notice here that I have the absolute value of 4 times x plus 3 minus 3. And I need to figure out what that equals if x equals 2. So all I literally have to do is plug in that value for x and solve for whatever I have. So let me begin here. Absolute value of 4 times x, again, I like to show times with parentheses, plus 3 absolute value minus 3. So that is the pre-step that I'm kind of building you guys up for. If you can do that, you're going to be golden, because now all you have to do is exactly what we did in the first 3 problems. So let's go ahead and figure this out. Again, we have a lot of stuff in the absolute values. Always figure out what those are. 4 times 2 is 8. Don't forget to add your 3. 8 plus 3 is 11. Absolute value of 11 is 11. Now keep in mind that I kind of just solved everything there, and I ignore this -3. I'm gonna go back and make sure that I'm -3 at the end of my end result. 11 minus 3 is a +8, and that is absolutely it. Now I am absolutely confident that you guys are capable of solving these problems with substituting. And hopefully my goal is to get through all the problems. And if you have any other questions on these specific problems, let me know, because I definitely want to go through solving equations, which is what we're going to cover now. All right, so let me pause this real quick. All right, guys, so you notice in the prior problems, what we did there is we started off with evaluating very specific expressions involving absolute values, and then we substituted a value, and now we're going to start doing equations. Now, there is one thing that you have to remember when solving absolute value equations, and it literally has to do with actual absolute value equations and its definition. Now, let me give you a very, very basic expression, so that way we can tackle it, understand why in the world are we going to have to look out for something or remember something specific. All right, so whenever you have an equation, what you're really doing is looking for a value that makes the equation true. So let's say I have a value that I want to find. This specific value, I want it to be a specific distance away from 0. So again, I am looking for a value of x whose distance away from 0 is equal to, I don't know, some distance. Let's just call it 8. So when you guys see an absolute value equation like we do here, I want you to know the definition of absolute values while solving them. So that way you have that deep conceptual understanding. We're not just being mechanical with it. I want you to see this and be like, okay, this guy is telling me to find a specific x whose distance away from 0 is equal to 8. Now let's think about this. If I'm looking for a number whose distance away from 0 is 8, what values could that be? What number is a distance away from 0, 8 units away? Well, let me visually show you an example. Here is my value 0. If I go 8 units in the positive direction, what integer have I arrived to? 8, right? Because 8 is 8 units away. Now keep in mind that when you're doing a distance away from 0, there's a positive direction and there's also a negative direction. So what happens if I go 8 units in the opposite direction? What unit do I end up in? what unit, what integer do I enter?
-8.
Negative.
Absolutely right. Now, what does this have to do with equations? Because you need to be thinking this. Of course, you want to get mechanical with it because this is about speed as well. When you see equations, you go, okay, I'm looking for a value of x whose distance away from 0 is 8. Well, I know that there are two directions I can go. So I'm going to set everything inside of my absolute values equal to a positive distance. Because if I go to the positive distance, I get positive 8. And then I'm also going to set the inside equal to a negative distance the opposite way. So, when you have absolute value equations, you're already
the
have
only one.
two solutions, and that's pretty
What?
much it.
So if
I only have to win once?
All right, so if I look at number one, keep in mind that you have an equation that you're asked to solve for. That specific equation has an absolute value. So remember what I suggest or what I hope you guys are thinking while solving these. I know the absolute value of a number is its distance away from 0. I know when I'm dealing with equations, they're asking me to find specific values. So if I look at this x here, I am asking you to find a value of x that when you subtract 1, its distance away from 0 is 7. Now keep in mind that when I ever ask you to find an absolute value, or if I tell you to find a number whose distance is away from 0 units away, there is a positive and a negative direction. So I'm going to train my mind to go, okay, this absolute value needs to be 7 units in the positive direction. That's why I set it equal to a positive solution. And the inside also has to be equal to a negative. Because again, there are two directions that you could be units away from 0. Now notice what I really did here is just create two equations. Once you create those two equations,
So-
you don't have to worry about the
So
absolute
do you
value.
want us to write both equations?
Yes, because there are two different solutions. You'll notice that when you write those two equations, you have to solve for them now to find that specific value. So I'm going to add 1 and 1 to both sides. Notice that x is going to be equal to a positive 8, which makes sense because if you were to plug it in, 8 minus 1 is 7. The absolute value of 7 would equal 7. You found the number that's 7 away in the positive direction. But you could also do it in the negative direction. So let's go ahead and add 1 both sides to the negative 7 because we have to create the other side. And x is going to be equal to a negative 6. Now, what would happen if I plug in a negative 6 in? Well, negative 6 minus 1 is a negative 7. The absolute value of negative 7 is 7. So notice that there are two solutions. That's why you have to write the two equations in order to find those two solutions. All right, so this one is a kind of a basics trying to get the kind of the flow going of what you're doing. Attempt number 2, if you're feeling pretty confident, go ahead and do 3. Just watch out for the 7. There is some pre-work you have to do before you make your two equations. If you're like, oh, I'm not quite confident, just take a break. I'll give you guys a quick, like probably minute to finish this problem. And then we could go over this example 1, and then you can try a couple more after that. All right, so number 2 again, I have an equation. That equation has an absolute value. Now, what is that absolute value telling me to do, or what am I really solving for in this equation? And that answer would be that I'm looking for a specific value of x, that when I add 12, its distance away from 0 is a positive 9. So if I'm looking for a distance away from 0 that is 9 units away, well, I know that there are two directions. That means I'm going to set the inside equal to a positive 9 because that's in the positive direction. And then I'm also going to set it equal to a negative solution because that would be in the opposite distance, the negative distance. And now that I have these two equations, I can solve for them separately. Now solving for this x, I'm going to minus 12 on both sides, end up with x is equal to a negative 3. Now you can always go back and check. Negative 3 plus 12 is a positive 9. Absolute value 9 is 9. So that one checks out. Let's go ahead and solve this one. Let me minus 12 on both sides. X is equal to negative 9 minus 12, which equals a negative 21. And then negative 21 plus 12 would equal a negative 9. Absolute value of negative 9 equals 9. So even when I plug these back in, the equations are true. So I know I found my solutions. So these are what I like to call level 1 because there's nothing really too pretty worried about. Now, numbers 3 through 8 are gonna take a little bit more work. Let's start with number 3 here. Notice that I highlighted that 7 because I want to bring attention to it. This equation here is pretty much the same thing, but you're doing something slightly different. You're looking for a value of x, and when you multiply it by 4 minus 13, its distance away from 0 times, or its distance away from 0 times 7 equals 21. So notice here that the main thing I'm trying to get at here is it gets super complicated when you start adding things outside of the absolute value. You notice that all these problems have stuff outside. You need to isolate the absolute value before you do your two equations. So you need to get rid of that 7. That 7 is multiplying the absolute value, so get rid of it. The opposite of multiplying is dividing. Dividing by 7, these subtract out, you're left with 4x minus 13. Absolute value of all that is equal to a positive 3. Now that your absolute value is by itself, now you can set your two equations and solve for them. So let's set the inside equal to a positive, and let's set the inside equal to a negative. And now you can go ahead and solve for those separately and you'll be good to go. So let's go ahead and do that. I'm going to add 13 to both sides. I end up with 4x is equal to a positive 16. Dividing by 4 on both sides, x is equal to a positive 4. Looking at the other one, I'm going to add 13 to both sides. You end up with 4x is equal to a positive 10. Dividing by 4 on both sides, you'll notice that x is equal to 10 over 4. Now keep in mind that you can reduce this fraction, so you are going to be required to. 2 divides the numerator and the denominator, so you end up with 5 over 2. So I know it's a little bit everywhere, but again, that's pretty much the basics. You have to isolate everything outside of your absolute value before you can make your two equations. So go ahead and try number, which ones did we have? Let's try number 5. Don't worry about number 6. I think you'll be okay with one example. If you're feeling confident, go ahead and do 7. Now keep in mind the definition of absolute value because number 7 is tricky. If you're doing more than 2 steps on number 7, there's something you didn't think about. So try to attempt them and we'll see where we go from there. So try 5, go on to 7, and then we're almost done. So with that being said, I see here that I'm looking for value of x. I want to multiply by 5, 3 minus that number, absolute value of that times 3, minus 3 is equal to 18. So get rid of everything else around. Now remember what you have to get rid of first. Always get rid of what you're adding and subtracting first. So I'm going to add 3 to both sides. 3 times the absolute value of 3 minus 5x is equal to a positive 21. Finally, get rid of that 3 on the outside and notice that 3 minus 5x, absolute value of that, is equal to a positive 7. So now you can forget about your original equation. Just treat this like the basic ones that we've been doing. We know we have to set the inside 3 minus 5x equal to a positive solution. Because again, what am I doing? Finding the distance away from 0. And then set the inside equal to a negative. And just solve for these separately. So I'm going to go ahead and do this one over here. Minus 3 on both sides. You end up with the negative 5x is equal to a positive 4. Dividing by negative 5, you finally end up with x is equal to a negative 4/5. Now there's no way to reduce 4/5, so I'm going to leave it exactly like the way it is. Concentrating on the other problem, I'm going to minus 3 on both sides. Negative 5x is equal to a negative 10. Dividing by negative 5 on both sides, you finally end up with x is equal to a positive 2. So those are your two solutions. You plug those in and you're going to be correct. It'll be good. Any questions before I start number 7?
No.
All right, cool. So
Nope.
let's look at number 7 together here before we start going crazy into it, because there's something that happens. And there's no way to mathematically know because the numbers work out, but you have to remember the definition of absolute values and what you are doing overall. For instance, this one looks a lot simpler than the one we just did, but I'm just treat it the same. I need to get rid of that negative 5 before I can take my two equations. So I'm going to go ahead and divide by negative 5 on both sides. So you end up with x plus 1, absolute value of all that stuff is equal to a negative 2. Now remind yourself what you are doing with solving absolute values. You're looking for this value of x, and when you add 1, its distance away from 0 is equal to -2. Now, can anyone kind of see what's wrong with that statement? I don't know, whoever.
I have no idea.
No idea, none? All right, so let's try to visually kind of give us a clue here. Here is my number line. I am looking for something whose distance away from 0 is -2. I don't know, what do you think, Saleti? You want to go on a -2 mile run today?
Yeah, sure.
No, because what in the world is distance? Can distance ever be negative? Can you go on a -2 mile run?
No.
No, not really. So notice that technically, as you know, trivial as it sounds in a way, distance cannot be negative. So what you're doing here mathematically is you're asking yourself to find a distance that is equal to -2, and you can't do that. So when you ever arrive to an isolated absolute value that's equal to a negative, that is what is considered a no solution. It's impossible. There is no way that you could find a distance that's -2 away. So you have to kind of, and of course you can do the math and the numbers will work out to something, but if you go back to the definition, it won't work. So keep a lookout for those problems. If you ever end up with an absolute value equal to a negative, just say it's a no solution. Now, one thing I want to forewarn you is that notice that although this problem seems like it's it's a no solution, you still haven't isolated your absolute value. So notice that after I divided by -2 on both sides, I would end up with 3x plus 1. Absolute value of all that is equal to a +2. So do not skip steps and go ahead and call it a no solution if you haven't isolated your absolute value first. Okay. All right, one more problem, and I think we'll call it a day after this. And what do you think, Mr. Kevin? What's the difference between number 1 that's different than all the other problems?
Got an X on both sides.
You have an X on both sides. Now, whether you saw that or read the directions, because that's what I want to emphasize, that you need to change the mindset. When you look at an absolute value and there's X's on both sides, your mindset changes just a tad. And I'm going to show you where it should change. So has my basic thought process changed on what I'm trying to do? And the answer is no. They're still looking for a value of X. And add 6, its distance away from 0 is 3 times that same value -2. So you're still solving an equation with the basics that we've been doing, except notice that now we have to watch out for things a little bit more. So with that being said, let's go ahead and solve this like normal. If I look at the both sides of this equation, notice that my absolute value is already isolated. So that means I'm just going to go ahead and set it equal to a positive solution, which is 3x minus 2. And then I'm going to take the inside of that absolute value and set it equal to a negative solution. Now keep in mind that there's multiple things. So I'm going to go ahead and put that in parentheses so that way I can group it, because that's really all parentheses do. They group things. And I'm going to be like, okay, I'm going to take a negative of that. And you'll notice there that it's super important to remember that, because once you see those parentheses, you know you have to distribute that negative throughout. I'm going to go ahead and solve this one first instead of the first one that I created, just to put an emphasis on it. So I know that there's a negative there. I have to distribute it. So I end up with a negative 3x plus 2, because again, I distributed that negative. Be careful of that. X plus 6 stays the same. Now I notice that I just have an algebra 1 equation. I have x's on both sides. I'm going to move the 3x over to this side to combine them. I end up with 4x plus 6 is equal to a positive 2. Minusing 6 on both sides, you end up with 4x is equal to a negative 4. Finally, dividing by 4, you end up with x is equal to a negative 1. Now, let's go ahead and solve the first one. So minusing x on this one, you end up with x6 is equal to 2x minus 2. Don't forget to add 2 and add 2 to both sides to end up with 8 is equal to 2x. Dividing by 4 on both sides. Oops. I'm over here telling the answer before I go. Dividing by 2 on both sides will give you that 4, which equals x. All right, so if you weren't paying attention to me, that is okay, because this is very kind of just repeated. But this is where you want to pay attention because this is where things get a little bit weird. Now, if you remember the past problem, what is the number one thing that we always had to watch out for?
The number on the outside?
The number on the outside of the absolute value, what it's equal to. If it's negative, you cannot find a value whose distance away from zero is negative. Now, notice that I did the math, I ended up with two solutions. Now, if I look at this first one, notice that the absolute value is equal to 3x minus 2. Now, depending on what I plug in, 3x minus 2 is either positive or negative. You have to double check your solutions to see if this is true. Let's go ahead and plug in a 4. 3 times 4 nowadays is,
12.
then you minus the 2, it equals 10. This is a legit solution. You end up with a positive, but let's try the -1 and see if something happens. 3 times -1 is a -3. And if you minus 2, you end up with -5. Now, can we have an absolute value equal to a negative?
No.
No.
No, so this is what is called, well, technically, there's not.
No solution?
Yeah, but well, this is not a solution, but this one is.
So what do you call it then?
So you just say that x equals 4, but you have to somehow mathematically tell me that this doesn't work, either by crossing it out or not putting it, because on your guys' exam and stuff, I'm gonna have, hey, put the solutions. And you have to make sure not to include this one because it's not a solution. It doesn't work in this situation.
Okay, sounds good.
Okay, sounds good. Well, that's good to hear. Give me a second to find the thing. Here we go.